third of three videos for a single example in the book where we're talking about mediation analysis, and we're in order to kind of explore mediation analysis, we're using an example given in the book that doesn't have a number. It's called mediation example with binary variables. And so, like I said, this is the third part, and we covered a lot of ground in the first two parts with the total effect and controlled direct effect, and then in the second part, natural direct effect and natural indirect effect. And this video will very much reference those concepts as well as the problems that are presented in those videos. So it's almost certain that you will need to have watched those other two videos preceding this one to make sense of this one. Okay, so like I said, in part one, we looked at the total effect, how to calculate the total effect, and it was given here. Okay, so watch that video for that. But the book tells us that we can also find the total effect in a few different ways. So we can estimate it like this. We can just add the natural direct effect and the natural indirect effect, which we looked at those in the previous video in part two, when the systems are completely linear. Okay, and that's a major caveat. Okay, and we'll see how that plays out here in a little bit. Or as the natural direct effect minus what they call the natural indirect effect sub r. Okay, and so what is NIE sub r? All right. Well, the natural indirect effect. Well, we'll just look at the definition here. The natural indirect effect means that we hold treatment at 0, and we just change the mediator value, right, from the value it obtains when t equals 0 to the value it obtains when t equals 1. Okay. So we will look at this expression as well. Okay. But if you try to work through this, you may have had some similar problems, some problems similar to what I had. And so I'm going to march through this more or less in the order that I work through this, finding little cul-de-sacs and problems, because I think that if you were trying to solve this, you may have also found these same problems. Again, I think that this chapter in particular, because it's a little bit more advanced, I think that the authors maybe tried to simplify it, and in so doing omitted some critical things and maybe kind of edited some errors into the text, unfortunately, but that's okay. So let's get started here. Okay. Where do I want to be? Right here. Okay. So first, let's look at figure 4.1. So we're going to try to find the total effect using NDE plus NIE. I'm sorry for how this renders here in Colab. I don't like how it kind of marches down the page like that. But we'll go to figure 4.1, and we'll just see that this relationship holds. Okay. So again, looking at figure 4.1, looks like this, right? So hopefully you're familiar with that by now, especially if you've watched the other two videos or you're following along in the book. So does TE equal NDE plus NIE? Okay. Well, we already found, all right, that TE for that DAG is this. Okay. CA plus B or AC plus B, or some combination like that. Okay. And so what's the natural direct effect? Well, we already found that. Well, that's B. And how about the natural indirect effect? Well, that was AC, right? And so is it the case that for that DAG, total effect equals NDE plus NIE? Yes, exactly. Okay, great. That's perfect. What about for the numerical example presented in the book? This just says, for example. I mean the example represented in the book. Okay, so we found that the NDE was 0.32, and we found that the total effect was 0.46. All right, and that the NIE was well, okay, so we found that the NIE was 0.035. Okay, so this is this first expression here for a linear system, and we notice that this doesn't work. Okay, 0.46 does not equal 0.32 plus 0.035. Okay, so so there's that. This is what I want to say here. We saw, so this would suggest that the numerical example is not a linear system, and we saw hints of that, and I alluded to this in the first video, but we saw hints of that when we saw that we had two different controlled direct effects when we altered the value of m. Okay, so I make reference to that in that first video, but this was our first indication that we might not be dealing with a linear system anymore. All right. So let's try to apply the general formula for total effect using the natural direct effect and natural indirect effect, where we are now finding a modified NIE, right? This NIE sub r. Okay, and we already defined that, but in the book it's basically defined as going the opposite way with the mediator terms. Okay. So here we are right here. Okay, so we want to find this NIE sub r term here, right? We already have the total effect, we know what that is, and we already have the natural direct effect. And so the rest of this is just trying to find NIE sub r. Okay, the expression for that is right here. Okay, so all I've done is I've taken the NIE expression that's given to us in the book, and then flipped the effects of m. Okay, or the order of m. So now when we do that, it doesn't work. Okay, it doesn't work. So so this was flummoxing. So so I felt like I had done what the book prescribed in order to find this, but it turned out that how it is described in the book is just slightly misleading, or it was misleading for me. I continued to hold t equal to 0, and then flipped the order of the mediators, which one was being subtracted from which, and I did this just based on the wording in the book. But it turns out that we also need to for NIER, we need to set t equal to 1 rather than t equals 0. Okay, so now I take this same expression and I make that change, right? So all the t equals 0 becomes t equals 1. Run through the math, and now we finally get this. We finally get the total effect equals total effect. Okay, NDE plus, or NDE minus NIE sub r. Okay. So again, what this means is that we don't have a linear system anymore. Or stated differently, the numbers that are presented in the book for the example are coming from a nonlinear system. And this got me wondering: is there a generic way that we can represent TE as NDE plus NIE plus something else, right? This seems a little bit contrived. I mean, not that it doesn't work. It does. It works perfect. But it's also not intuitive. Like, how do you subtract the NIER and what's the NI? It just doesn't have an intuitive feel for it. And so is there a way to just kind of modify this linear expression here to account for that nonlinearity? And there kind of is. So where are we at here? Okay, right here. So what we're going to do is we're going to modify that by adding an interaction term here. Okay. Now, in this case, we already know what the interaction term has to be, right? Because we know the natural direct effect and the indirect effect, and we know the total effect, and the extent to which this doesn't, the extent to which the total effect is not equal to the sum of the natural direct effect and indirect effect must be this, interaction term here. Okay, so we already know that it has to be this value, but can we derive that? Or can we find, can we just find an expression for this interaction term, rather than just relying on the kind of this backfitting of finding the difference between the left-hand side and the right-hand side and just calling the rest the interaction term. So we can do that. Okay, and so here's an expression for the interaction term, and it's reasonably straightforward. So we're just looking at the value of y under the two conditions. Okay, and we're finding their difference, and then we're just we're taking and then we multiply it by the difference in probabilities when n equals whatever particular value. We marginalize over all values of m, takes on whatever value when t is its two conditions. Okay, and so this represents our interaction term, and so if we push through all of that, we get exactly the term that needs to be to make TE equal TE. So that's good. So what we've done for kind of from the last two sections, right, from here to here, was all focused on the numerical example. Okay. So now let's shift our focus back to our DAGs, to figure 4.1 and 4.1c. Okay, the non-confounded case up here and the confounded case down here. Okay, and so we let's apply counterfactual analysis to all this. Okay, so we know that total effect has to equal this, right? We already found that, and so NDE is B, right? We already know that. We found that, and now we just have to find NIE sub R here. Okay, and so what is NIE sub R? Well, it's exactly this. It's the expected value of y when t is held constant at 1 under both conditions, and m goes from its value when t is 0 to its value when t equals 1. Okay, and we just push through again with the counterfactual analysis. This counterfactual analysis is proving more and more useful through all of this, so maybe it's worth exploring. But we push through with our counterfactual analysis, and we come to this, which is what TE equals. Okay. And what about figure 4.1c? Again, this is the one that has W terms in the mix. And as we've seen many times, when we have W in the mix for this counterfactual analysis, because W is not defined in our counterfactual scenarios, it just ends up canceling out when we do this subtraction, between the two conditions, and we get the exact same answer here. Okay, so that is the end of this example. And again, in this example, I tried to explore these different ideas that are being presented for mediation with counterfactuals. At this point, there are just 1, 2, 3 actual questions, study questions left in this section, and so we're just about done with the book. And I don't think any of the study questions, I haven't looked at them yet, but I do not think that they can be possibly as difficult as these were, trying to navigate all of these blind alleys and possible errors in the book. So if you got all that, then the rest should be a breeze. Okay, we'll call that good.